Okay, so a passenger weighing at 598 newtons rides in an elevator. What is the apparent weight of the passenger in each of the following situations? In each case, the magnitude of the elevator's acceleration is 0.500 meters per second squared. So, part A of the question asks, is the passenger on the first floor and has pushed the button for the 15th floor, the elevator is beginning to move upward. And B, the elevator is slowing down as it nears the 15th floor. So, the first thing I started to do when I did this was I did a free body diagram each case of the passenger. On the left is the force body diagram with an elevator of upward force, and then right is the one with downward acceleration. The apparent weight is going to be equal to the magnitude of the exerted force of the passenger. And the only other force, so you have normal force in the first one and weight in the second one. And I was able to use Newton's second law, to find the normal weight and the acceleration that was given. So what we know is that the weight is equal to 598 newtons, and the magnitude of acceleration is 0.5 meters per second squared, and we're left with the apparent weight of the passenger. Now for part A, I let the positive y-axis be upward, and it starts up from the first floor and accelerates in the upward direction as the speeds increases. And since the elevator's acceleration is upward, the acceleration in the y has to be greater than 0. So we kind of expected the apparent weight to be, equal to the normal force and be greater than the true rate. So the formula is pushed up with a greater force. So then going by Newton's second law, which states that sum of the forces in the y direction is equal to the normal force minus the weight is equal to mass times acceleration in the y direction. Since W is equal to mg, m is, we get our formula, m is equal to W divided by g. And then we find that the apparent weight is equal to the normal force, which is equal to the weight plus the mass times the acceleration in the y direction, which is equal to the weight plus the weight divided by gravity times acceleration in the y direction is equal to the weight times 1 plus acceleration in the y direction divided by g. And once I plugged in all my things for that, I get 629 newtons. And then when the elevator approaches the 15th floor, we're moving on to part B. So it's going to be slowing down while still moving upward though. So its acceleration is going to be downward, which means that the acceleration in the y direction is going to be less than 0. Now the apparent weight is less than the true weight because it's slowing down once it gets up there. So again, the formula is the sum of the forces in the y direction is equal to the normal force minus the W, which is equal to mass times acceleration. But the acceleration in the y direction is going to be negative 0.500 meters per second squared. And this is the same formula which is applied here, which is n is equal to W times 1 plus acceleration in the y direction divided by gravity. And we plug that formula in with our previous one to get the apparent weight, which is this, which is 598 newtons times 1, which is 1 plus negative 0.500 meters per second squared, divided by 9.8 meters per second squared, which is equal to 567 newtons.